In the previous two videos, we actually talked about how to transform a z transfer function into a state space. So I say that in the previous video that in the last previous video, we actually make things a little bit complicated for you. Alright, we say that a lot of stuff we don't understand. But anyway, I'll just briefly go through the key step and the things that you may want to know, and hopefully you can understand fully better. Alright, the first thing over here, this is your transfer function. Alright, at first it was t squared over 2 z plus 1 z minus 1 square. Now I say that this thing over here I have to write in terms of the numerator. So because this thing over here I can rewrite as t squared over 2 z plus 1, alright, z minus 1 square. Alright, I want to write the constant as part of the numerator because we say that it is a good practice to do that in terms of state space. Alright, because eventually you'll derive the answer lah. Alright, so nonetheless you just rewrite as this form, and then next you rearrange. As we have said, I will assume that you really understand the rearranging parts. At this particular part you need to know how to split it up into this form. Okay, so minus 2y you split it as this form, and then next you write in terms of the Euler's formula. You take a look, it's in terms of Euler's formula also, okay, with a little bit twist and turn, but anyway it still looks like a Euler's formula. Then next I rearrange by moving these two terms to the other side, and I bring this term to the other side, so I form the equation 1. Alright, the equation over here, as you can see. Okay, so just if you want to copy, you can just take this time to copy down, pause the video and copy this. Alright, just you can screenshot and then you paste it in the picture, and it's your picture now. Okay, but nonetheless this equation 1 will be something that we'll be keep using all along. Okay, and for equation 1 there is two things, and using the equation 1 we can derive x1k plus 1, alright, which is in this section, and we can derive x2k plus 1, which is in this section. So the left hand side is this one, while the left hand side is x2, the right hand side is x1k plus 1. Alright, so this is the derivations all along. Okay, so then you can copy this part first, or you can just copy this part first. Alright, pause the video and just screenshot. Next you can just copy this part now. Alright, just screenshot or copy. Okay, and then this thing over here you can also screenshot and copy lah. Okay, so now I'm gonna explain to you how do we derive somewhat there. Alright, we need to first know that x1k is equals to yk. I think this is a standard step. Often you're gonna write x1k is equals to yk. Okay, and often you're gonna write x2k is equals to something like this. So this is the standard way of writing things, I would assume. Alright, where this thing over here is Euler's formula. Alright, just take it lah, just take it. It's life lah, huh? And then so if you have a time shift of x2k plus 1 over here, you have a time shift of plus 1, you can shift everything, right? So k plus 1 over here, you shift plus 1, you have k plus 2. Yk you shift to k plus 1. Uk you shift to uk plus 1, as you can see, right? So we use all these definitions that comes from nowhere, just accept it, and that's life. Alright, so we use these two formulas, and in fact this third one also, alright, to derive our understanding of x2k plus 1. So for example, this is the equation 1 that we have derived just now, correct, which is this one, right? And then we write this thing as x2k plus 1, right? Because we say that x2k plus 1 is this one. You see, if I were to just copy this thing, okay, and bring it over here, take a look. This thing over here is equals to this thing, right? Just take a look. Yeah, this thing over here is this one, this thing over here is this one, same lah. Alright, so I can re-represent my sorry, this thing over here I can re-represent as s2k plus 1, which is this one. So over here I prove to you that this thing is your x2k plus 1. Right, this is some part of in the previous video. Alright, it's also you can see, right, Tiobo? Then more clearly lah, okay? Now this thing over here and this thing over here is the same. So this thing is equals to this thing. So therefore I can rewrite this thing as x2k plus 1. Okay? And next, this thing over here is equals to what? Alright, your k2x is equals to this thing. Right? x2k, this thing is x2k plus 1, this is x2k. Tiobo. So if I want to write in terms of this form, I shift this minus 2 to the other side. So what I will have is x2k plus t over 2 uk. Right, when I shift this thing to the other side, this one will become plus. So, you know, this thing. And this thing over here is equals to this lah. You see? So therefore this is the same as this. Right? So I'll rewrite this thing as equals to this. And this is why I rewrite as this. So many this and this and this. Yama. But anyway, this is equals to this. Okay? We'll just read lah. Huh? Then t over 2 uk, just simply write as that. That's all. Okay, and then you rearrange, you'll get your x2k plus 1 as this form. So this is your third equation. Alright? This is for when you're trying to find your x2k plus 1. Now I'm going to find my x1k plus 1. Okay? So in order to derive x1k plus 1, you use your particular this thing over here. Alright, equation 1. Tiobo. Or your equation 1. Or I just bring it all over your equation 1. Alright, I bring it all over here. Okay? Next, over here I know that this thing over here is my x2k plus 1 from the previous understanding, right? This thing over here I know is equals to this, which is x2k plus 1. Right, so I rewrite as x2k plus 1. Then I know that x2k plus 1 is equals to x2k plus tuk, which is what we have shown you just now. Right, which is equation 3. We have derived and show you that. So therefore I can simply rewrite this thing as equals to this thing if this thing is equals to this thing, and therefore this is over here now. Sorry, where am I? And therefore this is over here. Yeah. Okay. So in other words, this thing is equals to this. So I write it as over here, as you can see. Right? Okay, that will be better. Alright, I'll just rearrange stuff. Alright. So we know that this thing is equals to x2k plus 1. Alright, this is this one. Right? So therefore x2k plus 1 is equals to x2 this. So I can say that this thing over here is this thing. That's all. Okay? While this part over here, yk plus 1 minus yk, alright, you know that yk is equals to x1k. It is all the way coming back from this boundary condition. Not boundary lah, but rather than the given stuff. We sub in x1 as y. Alright? So yk I change to x1k, as you can see. Then yk plus 1 I change to x1k plus 1. It's just simply that lah. Alright? And then the rest are the same. I have this thing over here. Right? Then I'll rearrange in terms of x1k plus 1 Tiobo. So I rearrange in terms of this. So everything I move to the other side, this thing over here I move to the other side. So I have this form. Then I multiply everything by t because I want to represent my x1k plus 1 So if I were to multiply everything by t, I would have this form. Tiobo. Yeah, this form. And therefore I have my x1k plus 1 over here. Then my x2k plus 1 over at the side. So I can or in other words, this one okay, this whole thing. Or in other words, this one. So since you have your x2k plus 1 and you have your x1k plus 1, alright, I'll just simply rearrange in this form, right? And then after that, I set up the state space. I have my state space analysis all over here already, as you can see. So this is how we derive everything lah. So the only confusion part is actually talking about this thing. And the portion where we find our x2k plus 1 and x1k plus 1. The rearrangement and things like that and subbing in is really very tedious. Okay? So last but not least, because along chatting about this thing, I rearrange a little bit stuff. Alright, so in order not to confuse you, I'll just let you take screenshot again. Alright, just screenshot and paste inside your pin. And over here, you take screenshot. Alright, take screenshot. So this thing over here, I'm calling you to take screenshot over here lah, okay? Then now you can take screenshot over here. Okay? Okay? Now you're gonna take screenshot of this thing. Okay, and that's all. So you have derived your state space in a sense that this thing you need to really know how to manipulate. After you know this, I think this is standard. Alright, this is also standard. Alright, so once you know this standard form, you rearrange stuff, you should get a thing or two. Alright, so the rearranging over here is one cheat code. Alright, and another cheat code is that in order to find this thing, alright, you still remember we actually rearranging your x2k, alright, in terms of this form. So this form over here is this one, so you subthink this one as this one. So this is the critical step. It's really a critical step, really. I took 3 days lah. Okay, 3 days. I'm not to exaggerate lah. About 3 days to actually realize this step. Right. I've just mentioned to you already lah, the key rearrangement. Alright, so this is it for the state space. Yeah, so yeah.